So today we'll be talking about compound interest. And what we're going to do is we're going to do a little review on simple interest and show how that gives you the concept of compound interest. Now, one of the greatest mathematicians on the planet said one of the most powerful things in nature was a thing called compound interest. And we use compound interest in money to make money all the time. And we're going to spend a little bit of time understanding how it relates to the simple interest we learned in the last unit. Now, we learned in the last unit of a thing called simple interest. And remember, there was an equation that was associated with it. And that equation was I is equal to PRT. And you want to think of that as the money paid on a loan or an investment. And you want to think of this as a percentage of a principal over a certain amount of time. Now, let's just go through the final descriptions of all of these other concepts that we learned, that we're going to learn today with respect to compound interest. Now, you can still think of the principal as the initial investment or the starting amount of the loan. And the amount or future value of an investment includes the principal and the accumulated interest. So before, we used to use this equation to kind of represent it. And basically that was just the amount was equal to the interest plus the principal. Okay? Sometimes we wrote P plus I, doesn't really matter. Now, when we talk about the compound interest, we're talking about this. So instead of interest being paid on the number of years that something has been in there, instead we get interest paid for every compounding time. In essence, we end up with a thing called interest on the interest. I know it sounds confusing at this moment, but I guarantee you later on you're going to see how this works with the concept of simple interest as its base. So when we were looking at simple interest before, right? Simple interest was just calculated on the initial value that was invested, right? And we used to call that the principal. Now, at an interest rate R, we calculated the interest, right? And then we multiplied that by a period of time to get the total interest on the principal, right? So that's why we use the concept of I was equal to PRT, right? So let's just go over the concepts of simple interest again with a quick review of our simple interest triangle, okay? So remember with our simple interest formula, I was equal to PRT, right? So if we were looking for I, all we would do is get rid of this and then look at what's left over in our triangle, and we realize that's just I equaling PRT. Now, in order to calculate our R value, we need to basically just get rid of R in this entire equation, and then we realize that R is going to be I divided by whatever's left over in our triangle, and we end up with P times T. So if we were looking for what we call P, the principal, using I as PRT, then we're going to get the following. I divided by R times T. And what is cool about that is that We can also find out what our t value is, the amount of time is, if we know the principal, the rate, and the interest that we earned. So in this case, when we go and get rid of t in our triangle, we end up with I divided by PR. And we're done. Now, the last thing I need you to remember is this. The most important equation for calculating amounts is going to be A is equal to P plus I. You could also use A is equal to P plus PRT. If you think about it, PRT is just I, isn't it? Right? And then if you wanted to, you could do this other equation. A is equal to P bracket 1 plus RT. You can choose to use either one of those three to calculate the amounts of money that I make at the end of my investment. Okay? Now, this is the last thing I need you to remember about your calculations with simple interest. Remember, for every year, we have a certain amount of time for months, and we end up with 12 months, right? You also got to remember that when you're talking about a year, there are also 52 weeks in a year. You should also remember that there are 365 days in every year. This helps us to calculate the various interest rates using simple interest. So let's go and do a simple problem here. So let's take a look at this example. This is example 1. It says $700 is invested for 5 years at 3% simple interest. How much interest is earned? In order to do this, we always have to start by realizing that if we're using the simple interest calculation, we have IPRT. So what you want to do is you want to write down all the variables that you have for the equation I is equal to PRT. Then what we do is we go and take all these numbers and put them with their respective variables. Once we know what they are, we can use the appropriate equation for this problem. So remember, take a look at the problem and fill out all the information you need. Now, let's go. Pause the video, fill out all the letters that we know, and then you will see how we're going to do the final interest calculation. Now, filling in our information, we know that P is 700 since it's our starting value. R is 3 over 100, which gives us 0.03 as the decimal. And T is equal to 5 because time is already in years. Punching that into equation, we have this. I is equal to PRT. We substitute 700.3 and 5, and we end up with. And when we finally substitute, get our answers, we end up with this. Therefore, $105 interest is earned. And we're done. Now, let's move on to the next problem. So now what we'll consider is a thing called the compound interest. Okay? We should be on page 2 by now. In order to find the compound interest, we have to set up a chart to calculate each compounding period separately. So remember, I told you this was interest upon interest, right? So let's take a look at this problem here where we're going to compare the growth of $1,000 earned at 7% interest for 5 years with something that has, say, $1,000 invested and compounded annually. Okay, so let's go and do our simple interest style calculations and share what we know with our IPRT. The first thing we have to understand is that the principal is $1,000. Let's write that out. The interest is going to be 7% every year. So I'm just going to do and write this out. So just remember 7% is the same as 0.07 because we just simply moved our decimal to the right 2 spaces. the time is still 5 years. So let's go and take a look at what would happen with something like this by calculating I is equal to PRT. So now what you have to realize is that when we calculate I is equal to PRT, our interest is going to be $350. Now, the last thing that we have to do is calculate the total amount of money that we have in this thing, right? We want to see how this money for simple interest compares to compound interest. So let's do that. So let's calculate the total amount of money. So that is going to be A is equal to P plus I. And that's just 1,000 plus 350. And that totals up to be about $1,300 for the total amount of simple interest. Okay? Now, the fact that we've taken this time to actually calculate the simple interest, we're going to go and see what happens when we go and apply compounding interest. So remember what I told you. We're going to actually see what happens over 5 years when we compound our money every year. Now, let me explain to you what's actually going to happen. In year one, when we basically put our money into the bank for the compound interest. So imagine this was our year column and this was year one. Okay? And we went and put our $1,000 in. So what's supposed to happen for compound interest is this. We're literally going to take the principal every single year and we're going to times it by, if you think about it, what did it say? The thing was going to be invested at 7% compounded annually. So that means that the principal is increased or gets an interest of 0.07, just like before. So remember, the interest rate was 7%. So what happens at the end of 1 year, it basically just takes simple interest and tax it on. Okay? So in this case, we're going to have 1,000 times 0.007 gives us 70. So at the end of the first year, we've got $1,070. So that is what would happen normally if we had, what would you call it? Simple interest. Now, here is the cool part about compounding. Remember that $1,070 that you had? It's going to, I want you to imagine that 1,070 starts at the beginning of year two. And then we go and apply that simple interest principal just for that year for 1,070. In this case, what we end up with when we take 1,070 and multiply by our 0.07, otherwise known as 7%, you end up with $74.90. Now, let's go and punch that into our calculator by adding up the money that we started with at the beginning of the year and the interest earned. So now you end up with a total of $1,144.90. And remember that money that we had at the end of the year? Now we're going to take that again and we're going to go and push it to the front of the next year. So now we have $1,144.90 starting at the beginning of the year 3. And this is so cool. Now we go and multiply by 7% again on that first amount of money that we started at the beginning of the year. And we do that again, and now we end up with $80.14. You notice how the interest is increasing? This is amazing. All right. And now you end up with $1,225.04. And now we're going to take that and move that last amount of money that we totaled in that year to year 4. Now, what I'd like you to do is I'd like you to pause the video, and I would like you to see if you can fill out the rest of this chart. I will show you the solution after you pause, do a little bit, and then we'll take a look at the solution. So now, when you look at this, the first column of this entire project here is P. This value here is I, isn't it? And this value at the end is A is equal to P plus I, isn't it? And we do that for every single column. And then we move our A to the beginning of the next year, and we get this chart. Now, give yourself a pat on the back if you got something similar to this. Now, the only issue that you might have is your rounding, so you got to watch your rounding. Remember, round to the nearest 2 decimals. Okay? Now, let's go and take a look at what this graph would look like. Okay? I'm just going to let you in on a secret that most people don't know. The concept is this. When you want to describe how the interest interest grows compared to simple interest, one graph is going to look like this, a straight line. And then another one, the other one, is going to look like this. Okay? Looks very similar to something that we took a look at a long time ago, right? You're going to realize that this is the case for the first graph. In this case, the simple interest is linear growth, and the compound interest is exponential growth. And what you want to realize is this, that when you look at the final answers for our growth, for our total amounts over 5 years, is that the compounding grows more rapidly than its counterpart as simple linear growth or simple interest. So compounding interest is way faster than exponential growth over time, and that's why we make investments in banks and stocks and mutual funds, which guarantees an interest at the end of each year. And so now let's look at this next problem. Okay? Carrie wants to invest $500 for 5 months, right? And we want to compare this simple interest for 5 months compared to 3% per year compounded annually. Okay, so let's just quickly do the simple interest for 5 months. Okay? When we do the simple interest for 5 months on $500, the principal is $500 and the rate is still 3%, otherwise known as 0.03. And that is per year. But now we have to consider the fact that we're doing this for 5 months out of a year. So we have to take our time, which has to be out of a year, and we have to say this is 5 divided by 12. And now this is what we get for I. And we get $6.25 for the I value. But remember that our time was 5 months. So the reason why we had to change it into years is because our times is in years. So we have to change this to be 5 months out of 12 months for every year. And then when we plug into our equation, we just put in 5 over 12 for T. And we get I is equal to $6.25. Now that we've got that, we have to calculate A. And this is how we calculate A for the simple interest. We get A is equal to P plus I, which is just 500 plus $6.25. So we end up with a total of $506.25 for the simple interest. Okay? So based on what we did, we looked at our $500 for 5 months. We compared the growth at 3% per year simple interest for 5 months. We're good. So now let's go and focus on the 3% per year compounded monthly. That 3% compounded monthly is calculated as such. So think about it. You have 3% per year. 3% is represented as 0.03. But this thing is compounded monthly, right? Per annum, it says per year compounded monthly. Per year compounded monthly. So that means we have to divide our 0.03 by 12. And that gives us a final answer for our rate to be 0.0025. So that is our interest rate for our compounding period. So in this case, the interest is always P times 0.0025. And that's what we always have to do. And remember, our starting amount is always P, and then we have A plus equals P plus I in the third column. So what I want you to do is I want you to imagine that this was the months. So at the end of the first month, we should have a total amount of money. So in this case, you're going to get the following. You start with 500, and now you take that 500, you're going to multiply it by 0.025 and put in our interest, and that just happens to be $1.25. And then the total amount would be $501.25. Now we need to take that and carry it down to the next month. So now at the start of the next month, you have $501.25. You're going to multiply that by 0.025, and you're going to get, again, $1.25. And that gives us $502.50. And we carry on. 502.50 carried down to the, well, isn't that the third month? And now we multiply by this constant rate for each month. And now you end up with, instead of $1.25, you end up with $1.26 due to rounding. So now you end up with a total of $503.76. And let's continue. Pause the video, do the last two sections, please. Last two rows. And now, when we take a look at the total amount of money that we make for each scenario, we find that, wait a second, the 506.28, oh my gosh, the simple interest just beats out. No, that's not the simple interest that beat out the compound interest. The compound interest just beat out the simple interest. So you would say the compound interest makes 3 cents more. And that's it. You're done. All right. Now, do your homework. Homework is on the website. Everything is good to go. All right. Have a good day. You'll be doing the following questions. I believe they are number 4, 6, 7, and 9. Good luck. Have a good day.